Doing good.
Good. Good to hear.
Wait, hold on. Okay.
Isn't technology fun?
Yeah, you were still on my Bluetooth, and so it was coming through my headphones. I was like, that's not right. I turned that off,
That's
and
fun.
my call volume was very low. So,
Yeah. Yeah, I'm using my wife's laptop to do this Google Hangouts so that it doesn't quit on me while I'm trying to figure out a question like it used to.
yeah.
So I'm doing that, and I tried to get on her Safari, and it crashed like 3 times. I'm like, what the crap?
Oh shoot.
So I had to restart it. But yeah, I mean, I guess that's not too big of a deal, but it's still annoying.
Yeah.
Um, well, I thought this week's stuff wasn't too bad.
Yeah.
Have you got to look at it much?
I saw the first video.
Okay.
I didn't get to the second one.
The second video is honestly going to be more confusing, but um, it's not too bad. Um, yeah, hopefully we can walk through it okay, and it won't be too big of a deal. But basically, it's just kind of algebra stuff where I guess technically it's trig, but you just kind of deal with it algebraically
Yeah.
with the unit circle
So
in mind and things like that. So,
we're just dealing with product to sum and sum to product identities. Is that it?
uh-huh. Yeah, and he did say in the video that we don't need to memorize any of these. We just need to know how to use them.
Oh, okay.
So that's good. Um, yeah, and they're not too bad either. You just plug it in, simplify, and you honestly don't even simplify that far.
Yeah.
Like it's he stops earlier than I would think to stop on those, but hey, I'm happy doing less work. Well, let's get going on the GHOA assignment then.
Okay.
Um, okay. All right, so it says begin reviewing your solutions from question 1 and 3 from the preparations assignment. So if we look at that, number 1 is not even a question. Cool. So yeah, product to sum to product identities. We don't really need to go over those because they're given. I don't know if you've been doing this or not, but I always go back to week 10 and open up the list of trigonometry.
Yeah, that's what I've been doing.
Okay. Yeah, that makes it way easier.
Yeah.
Okay. So we'll just look at those. Now 3 is find the exact values for either the product to sum or sum to product identities. I guess we could try those. Um, are you seeing this on the preparation assignment?
Oh, you're on the preparation?
Yeah, just because it says to, on the
Okay.
GHO assignment, it says to go back to these 2 questions on the preparation assignment and talk about it. So
Okay.
just trying to
All
be
right. On the preparation. Which one are we talking about?
number 3. So
Okay.
sine of 13 pi over 24. Let's start with that one. We'll just run through that really quick and then see if our answers match.
Okay.
Okay, did you get an answer?
What's that?
Did you get an answer yet?
Yeah.
Okay. What did you get?
So actually, before I say anything, so we're just kind of simplifying it, right?
Yeah.
Okay. So I got 1/2 times sine of 3 pi over 4 plus sine pi over 3.
Cool, me too.
Okay.
Checkmate on that one. I honestly have zero worries with those.
You have
So
worries
I
with
don't,
what?
with that style of question, I don't think.
Oh, yeah.
I guess this
Doesn't
next
feel like
one
that you
is,
can actually like solve the whole thing.
yeah.
Yeah.
Yeah, I like that you just plug it in, simplify a little, and you're done. Do you want to do the next one? I know that's the other identity, but
Sure.
I feel like it's the same process. All right, let's try it, I guess. Okay, did you get 2 sine of 45 degrees times cosine 30 degrees?
Yep.
Check. Good, I have no questions there. Okay. Spend time discussing question 5. Okay, so solve the following equations for A within that domain.
Okay, I don't know what to do here.
You don't?
No.
Okay. Basically, sine of A equals 1/2, right? So
Yeah.
on the unit circle, what equals 1/2? Well, pi over 6. Sine of pi over 6 gives you 1/2, right?
Okay,
And
yeah.
sine of 5 pi over 6 also gives you 1/2. And those are both within our domain of 0 to 2 pi. And so those are our 2 answers. Pi over 6 and 5 pi over 6. Easy as pie. So that one is not too bad. Tangent then would be a little more confusing. I'm not sure how you'd get that. -1 over root 3. So what sine, because tangent is sine over cosine, right?
Yeah.
So what of sine over cosine multiplied, or is that divided, would equal -1 over root 3? I really don't remember.
So 5 pi over 6. That one works, I think.
Yeah, I think you're right. So 5 pi over 6 is good, and
11.
11 pi over
Wait.
6?
Yeah, 11 pi over 6.
Yeah, that's what I think as well. So, yeah, basically that would be our 2 answers as well.
Yeah.
So with these, there's multiple answers. There can be anywhere from,
Yeah.
I think you said 2 to 4 answers. That'll make sense as we get further along. Now on question 5, this one's a little bit more involved because we have to do some algebra to set it up. So we need to factor that 4 cosine squared.
Okay.
I'm not exactly sure how to do that, so that we get 2 separate parentheses that multiply together to equal that.
Okay. So would it be like 2 cosine alpha and 2 cosine alpha, or 4 cosine alpha and 1 cosine alpha?
That is the question. Ugh. I don't know how to do that.
Let's see here. Oh, okay. I got it.
How do you break it out?
So, okay, if we're allowed to like use both sides of the equation, what you do is you add 3 to both sides. So you got 4 cosine squared of alpha equals 3.
Mm-hmm.
You divide each side by 4. So now you got cosine squared of alpha equals 3/4, and then you square root each side. So now you got cosine alpha equals square root of 3 over square root of 4, and square root of 4 is just 2. So you're left with square root of 3 over 2.
I'm confused. So, okay, so you factored out the 3?
No, I didn't factor out anything.
Okay, tell me where you started so I can follow it.
Okay, so I added 3 to both sides.
Okay.
So now we got 4 cosine squared of alpha equals 3.
Right.
Then you divide each side by 4.
Okay.
So now you got cosine squared of alpha equals 3/4.
Okay.
Then you square root both sides. So now you got cosine of alpha equals square root of 3 over square root of 4.
Cosine alpha. Hang on.
Okay.
So you divided by 4 and then did the square root?
Yes.
Hmm. So you got square root of 3 over 2 for cosine of alpha.
Yes. And the ones that match up with that are 11 pi over 6 and pi over 6.
Eleven pi over 6 and pi over 6. Okay. Those 2 answers are right, but it also shows that there's 2 more. For some reason that, oh, it's because since we came out of the square root on the one side, it has to be plus or minus.
Oh,
So we got, yeah, it's kind of weird. So plus or minus root 3 over 2. And so, yeah, you got 2 of the right answers and then just the negative of that to get the other 2.
Okay. So there's also 7 pi over 6 and 5 pi over 6.
Yes.
Okay.
Nice. Okay. Good job. Holy crap. That I would not have figured out. Okay. Oh, it's just alpha. I got it. All right, I'm in your meeting. Yeah, you can hang better. Nikki. It's just my brother.
Okay.
I live next door to my parents, so my siblings
cool.
come and visit sometimes. Yep. Well, that wasn't too bad. If we look at the next one, though, it gets a little hairier.
Yeah.
So, okay, I'll walk you through this one because you may be fresh enough on your algebra to think of this, but I definitely wouldn't have been.
All right.
So, cosecant alpha plus 1, and then the secant alpha minus 2. Basically, you can solve those separately for 0. And then you'll get like 2 answers from each one.
Oh, you can solve them separately? Is that what you said?
Yeah. If you have, like normally some of the questions we'll have to use identities to get it in that form that it's already in. And then from that form, you split the cosecant alpha plus 1 into one side and the secant alpha minus 2. Set each of those equal to 0 individually, and then solve, and you'll get 2 answers each, most likely. And those will be your answers for alpha. Does that kind of make sense?
Yeah.
So cosine alpha plus 1 equals 0, and secant alpha minus 2 equals 0.
All right. I think I got my answers.
Okay. Give me 1 second to see what I can come up with here. Is that cosecant? Oh, I did cosine. That's different. So cosecant x gets -1. Is that even possible? Oh, yeah.
What did you eat? Oh, yeah.
Did you get answers then?
Yeah, I got answers.
I'm struggling to imagine how to get an answer from cosecant.
Oh,
Or secant for that matter. But so cosecant is 1 over sine, right?
yeah.
Is it then, so what did you get for alpha on that side?
You're talking about the cosecant one?
Yeah.
So I got 3 pi over 2.
3 pi over 2.
Or I guess another way of saying it, sine of alpha equals -1.
Oh, okay. So does cosecant and sine equal the same things on the unit circle every time? Since it's just an inverse and -1 over 1, the inverse of that is like technically the same thing.
Maybe.
Okay. So 3 pi over 2, there's one answer for that. Secant then is 1 over cosine. Okay, and then did you get pi over 3 and 5 pi over 3 for the other one?
Yes.
Okay. Whew. All right, so we get 3 answers there.
Yep.
Cool. I think that's correct. Did you check the everything? Cool. Yep, we did it correctly. Sweet. All right, back to the GHOA then. Reduction theorem. Y equals. Okay, I didn't know that was called the reduction theorem, but I think I did it this, hang on. I think it's the same as what he did in the second video, just I don't think they called it that.
Oh.
The first 2 are probably fairly simple. Well, not that simple really, but you could do. The third one though, I don't really know what's going on there. So hopefully we don't have any that tricky until we can learn more. Maybe let's just walk through the example here. make sure we can understand what's going on, and then we can either try the extension problem after that or do the quiz.
Okay.
Okay, so tangent of 3x plus 1 equals square root of 2 secant 3x. Okay. Okay, so we'd want to simplify it to get the tangent and secant identity. I think that's a Pythagorean identity, right? Yeah. So we want tangent squared x plus 1 to equal secant squared x. Or, yeah. Okay. I'm confused how he gets from tangent 3x plus 1 squared, all of that squared. How does he get from plus 1 to minus 1 in part 3?
Wait, what?
So right before part 1, he like squares both sides of the equation, right? Getting, yeah, so he has tangent 3x plus 1, all of that squared at that point. And then he like multiplies it and then does something weird, and it turns out to be tangent of 3x minus 1, all of that squared later on, like in part 3. That doesn't make sense. How did he convert that to minus 1? Yeah, part 3 makes 0 sense to me.
I killed her. I need to die. I need to die so bad.
Okay. Does that make sense to you?
Which part?
I think I'm confused because I didn't actually write it down and follow it along, but I think he squares the left side, the tangent 3x plus 1, and then he squares the other side, uses the Pythagorean identity to convert it to terms of tangent, combines it all to one side, factors that back to the tangent 3x minus 1 squared that I was way confused about in part 3. And then from there it makes sense.
Oh.
Yeah, so what part are you confused about?
Probably just like I'm just like trying to wrap my head around when he square roots both sides.
Okay.
The first time and how he gets from that to that.
Yeah. I'm gonna draw it out and see if, because that's still kind of what I'm stuck on. Like, I'm not quite following that part. I'm just assuming that he did it right, and that if I did it, it would end up the same. And I should just do it, so I stop questioning it.
Okay.
So I'm gonna try that really fast. Can you close the door? Yeah, I did not get the same thing. I thought I was, but no, I definitely didn't.
Uh,
I don't. This is annoying. Like he doesn't give enough information here for you to
Yeah.
follow it. Like how does he go from tangent squared 3x plus 2 tangent 3x plus 1, all pluses, to a minus 1 when you factor it? Like that doesn't happen. If you have all pluses, you end up with a plus there when you factor it. Every time.
yeah.
So something's left out, or it's just a mistake. Yeah, I definitely got something different than him there, and I'm pretty confident in the way I did it. So that's really annoying. Well, Okay, well. I don't know how to do that extension problem either, though.
Mm. Well, I just peeked at the quiz, and doesn't look like it's on there. So
Okay. Aha! I knew it. Yeah, the GHOA assignment, there's an error on part 1.
oh, there's an error.
Yep. If you look at the key, there's a minus sign, or like there's a plus sign where there should be a minus sign, and the key shows the minus sign, but this doesn't,
Yeah.
and that changes everything. Yep. But I still didn't end up with that, so I'm still kind of lost. But I knew something was fishy. Okay. I feel like these ones are just ridiculously hard, and then the ones we get on quizzes and tests aren't as bad,
Yeah.
which I'm grateful for. All right, let's move on to the quiz then. I feel like I can do it if it's not like expert level.
Yeah.
Oh, this is weird. I'm confused. Match each expression with an equivalent expression? Oh, the ABCDE thing. Interesting. I got one of them.
For the first one?
Yeah.
Okay. I got 3 of them so far.
Nice. I'm slow. Hmm.
And now the first one's C, the second one's A, and then the fourth one's D.
Oh, yeah.
All right, I got the last 2.
I've only gotten 2 so far. Which one was E again?
E?
E. Like, which one did E match with?
So E is the last one.
Yeah.
And the only reason why I got that one is because it was the only one left.
Okay. Hmm. How did you, so did you basically just like start solving the A, B, C, D, E parts and trying to match them? Is that how you went about it?
Wait, I didn't quite catch that.
Did you try to solve the right side to match with the left? Is that what you
I
did?
tried to match the left side to the right.
Oh. A makes sense to me. A is the second one. C is the first one. That one's fairly simple. And the other ones I couldn't really figure out.
Oh, and I actually do know how to solve for E now.
Oh, you do?
Yeah.
So it's a cosine A, cosine B, right? So you use the product to sum identity, right?
Are you talking about E?
Yeah.
No, that's not what I did.
Okay. What did you do?
So, over on the left side, the last
Yeah.
one, 1 plus cosine of 6 over 2. I guess you could say I kind of cheated a little bit. So, with the cosine of 6, you can
Yeah.
do that as cosine 2 times 3.
Okay.
Because if you look at the identity sheet, there is a power reducing identity
Mm-hmm.
where it is 1 plus cosine 2x over 2. So if you change the 6 into 2 times 3, you can change that to the other identity, which is cosine squared of x. Which
Oh,
in
I
this
see.
case, it would be 3.
Ah. Okay. What the crap? Yeah, I definitely didn't do that one right. I tried to split it and not use the power reducing identity, but use the fourth product to sum identity, and that was just turning into gibberish.
Yeah.
But yeah, the power identity is way better. Plus cosine. Okay. So it's CA something something E. That's what I've got so far.
Okay. So it's CABDE.
CABDE. Okay. Sorry, I'm taking a long time.
No, it's all good. Do you need help?
I'm good. I just need to write it down well so we get credit for this stuff.
Yeah, it's all good.
Okay, so we want to go to terms of sign. What the heck? Five. Dang it. I'm not getting the right answer.
How's it going?
I'm not getting B.
Okay. I will give you a big hint. So go to the identity sheet and
Yeah.
look at the double angle identities, and I guarantee that you will find it.
Cosine 2x equals. Oh. Okay.
You got it?
Yeah. I was like trying to manipulate it to get in the right form, doing all sorts of
Yeah,
conversion.
they're just trying to be tricky. Threw in an old identity.
Ugh.
Oh, hold on a sec. Well, if anything, he could like text me or something. He has my number.
Cosine minus cosine. Okay. Oh, those are obnoxious, but I got it. So
Okay,
there's
cool.
evidence for all 5 now, so we should be good to move on.
Okay. Number 2 is an interesting one, though.
Okay, the proof of the first product to some identities is given to you in the book. The proofs for the other 3 identities can be found using similar techniques. Show the proof for one of the other 3 identities in the space below. Yikes. Well, I didn't look at the book, so I don't know what they're starting with. This quiz is a lot harder than the other quizzes.
Yeah. Probably because it's one of our last ones.
Convenient. Sweet.
You found it?
No, I don't have access to the e-text.
Wait, you do or you don't?
I don't.
What?
It comes up with an error when I open it. Oh, okay.
Do you want me to try and see if I can get in there?
I think I'm getting it.
Okay.
What? What are we on this week? I have to have like 20 tabs open to navigate stuff.
Let's see.
Oh,
'Cause it's
6.5 and 6.6.
Yeah.
So this one is, what's the question? Is it product and sum identity or? Yeah, product to sum identity. Okay. What the freak? Yeah. Apparently, I don't have a subscription to this site.
As we have seen already, many real-world applications use the trigonometric sine of 112.5 degrees. All right, let's look at some applications of this by talking about them. Sometimes it is useful to work the other way, which is to say, writing the sum of two trigonometric functions as a product. So let's look at the sum to product identity.
Yeah, I don't have access to the textbook for whatever reason.
Shoot.
So I don't know how to look up a proof to see what format it should be in.
I can't access the text either.
Convenient. And the problem is now we don't know which one is in the textbook, and so we don't know what the other one is.
Yeah. We could just like tell them like, hey, the e-text isn't working.
Yeah. Holy crap. What's weird is I see, like, I look it up on the internet and see, like, what the proofs are. And they basically use the product to sum identities to derive the other one, which I apparently closed. Oh, yeah, they use the product to sum identities. Oh, hang on. I'm confused. I am very confused. Time out. Oh, okay. So they use the sum and difference identities to get the product to sum identities. Okay, well, I'm just going to write one of these down.
Okay.
I'm going to assume that the first one is the one in the book. So I am going to do the second one.
Well, on the bright side, I got numbers 3 and 4 done.
Nice. Can't believe you're figuring this stuff out without watching that second video. I would not have understood any of this without watching that video. Okay, I've got number 2. There's a YouTube video that I'm actually going to add to a playlist. But yeah, there's a YouTube video that just like shows the identities.
Oh, okay.
And it's actually not difficult. It makes a lot of sense. So I just
Nice.
have to write a lot down to show it, but not too bad. So find all the angles alpha in that satisfy that equation. Yikes. Okay. So what did you do for number 3? Just to, before I get too
Number
far
3?
along, I want to make sure we have the same thought process.
Okay, so they did another little tricky trick in this one too.
Yeah.
So I went back over to the double angle identities, and so
Yeah.
sine of 2 alpha is the same as 2 sine alpha times cosine alpha.
Okay. Yeah.
So I changed that, and then I changed tangent to sine of alpha over cosine of alpha,
Okay.
and then I times each side by cosine of alpha over sine of alpha. So
Oh.
that crosses out the sines. So you got cosine alpha times 2 cosine alpha equals 0.
Yeah.
So then you times those two together.
Does that equal
So
0 or does that equal 1?
wait, what?
When you times the right side by cosine alpha over sine alpha, does that cancel?
Oh yeah, you're right. That would be 1.
1.
I messed up.
Okay, so that goes to 1.
Yep. So that's 1, and then so you times the cosine alpha by the 2 cosine alpha, and that gives you 2 cosine squared alpha.
Equals 1. Okay.
And then you divide each side by 2.
Yep. So cosine squared alpha equals 1/2.
Yep. And then you square each side, or square root each side. I mean, so that turns it into square root 2 over 2.
Okay, yeah.
So
And
cosine of alpha
cosine
equals
of
square
alpha.
root of 2 over 2. So that would be, you got pi over 4. That's 1. And 7 pi over 4.
Nice. Awesome. Yeah, that looks great. Once again, I don't know how you're getting that without watching the video, but that's perfect.
As long as I realize that there's an identity to go for it, and if it's just straight up algebra, I can normally get it.
Yeah, that's awesome. Okay, that makes sense to me. I don't know. I need to have more confidence in myself and just go for things. Instead of look at it and wonder, now do I do that?
Yeah.
Okay, so this one, we use the difference identity. Okay, so did you get 2 cosine of 150 degrees, sine of 145 degrees?
You said 135?
145.
145.
Sorry, 135. You're right.
Oh, okay. Just making sure. I was like, wait, what? Did I do
Yeah,
my
my
math wrong?
bad. My bad. Draw that good. Is that where you ended?
But yes, that
Okay.
is what I got.
That's where he ended in the videos, so I'm guessing that's where he wants us to end. Like, that doesn't seem simplified to me. I would take that to a calculator. But whatever. I'm content with that.
Yeah, it's all good. We got it done.
All right. Good deal. Well, we're done. Sorry to keep you waiting there at the end. I wanted to make sure that I was going to be able to finish before
Yeah, it's all good.
letting you go.
All right. Well, I guess I'll see you next week then.
Okay, yeah, sounds good. Thanks, Tyler.
Yep.
We'll see you later.
See ya.